Okay, can you hear me? Yeah, now it's working. So, welcome to this last session of the first day of TechEd Europe 2013. And I must admit, it's very impressive to see so many developers in a session talking about debugging. It's like admitting that you're writing buggy code. I don't know what to think about it. I don't know what to make of it, but I will accept that. The reason I'm doing this session is because I have a friend, and sometimes he might do some bugs in his code. So let's assume that you are actually here for the sake of your friends, not for the code that you are writing, and it has some problem. So I chose the name Advanced Debugging of ASP.NET Applications, and the reason for that was because I had encountered a couple of situations. I have clients, I was even working for a company at one time, and we had some performance issues with our application. And it's very difficult to understand what is happening if you don't know what tools to use and how you should use them and what exactly you need to expect from them. And one of the and I think this with the performance issues is one of the biggest challenges we can face. You can have other kind of errors like crashing, you can have high memory usage, you can have deadlocks and stuff like that. But I will concentrate on this particular session mainly on the performance part of the things and how you can use different tools actually to find out what might be wrong with your application. I must tell you that I done this session 3 weeks ago in New Orleans, and it crashed badly. I really did my part. My computer was actually not working anymore the way it should. The stuff I'm doing normally you shouldn't do in production. It's not like I want to do them, it's not like you want to do the kind of stuff I'm doing here in production, but one way or another, your product needs to go live, and of course then it's in production, and you might have problems, and you need to see how you can fix those. So, let's see. Who am I? My name is Tiberiu Kovac. I'm originally from Romania. The short version of my name is Tibi. I lived in Sweden for 15 years. After that, I got married, I got some kids in Sweden, and then of course I was thinking that it would be nice to take the family to live somewhere more exotic. So we chose Bermuda. We lived there for a period, and then we decided that it's time for us to go back to Romania. Since 2004, I'm a Microsoft certified trainer, meaning that for a living I train other people. I've done my part of working, I got to that incompetency level when I was a manager, and when I realized that I can't manage anymore, then I started to teach other people how to do their job. So that's what I mostly do, but I do a lot of mentoring as well. I help other projects to start using technologies, but even find problems and improve the quality of their applications. I'm a Microsoft MVP. MVP stands for Most Valuable Professional. The specialty is Windows Azure. Like most of the people, that's what Microsoft is, this is the Microsoft's direction right now. I'm a father, as I mentioned, I have 2 daughters, and I'm a geek, and I'm not afraid to admit it, so that's me. If you are on Twitter, you can find me as Tibor19. If you can use the hashtag MSTechEd, so Microsoft can actually track and see what's happening here. I put together a small agenda for today. We will look at some of the client tools. How can you find out what's wrong with your application, and how should you find this kind of information from the client side? Because sometimes everything starts like, my auntie or my granny or my mother calls me and tell me, oh, I was using that site of yours and it was very slow. Of course, if you have to listen to her, it can be her computer, it could be something else. So I don't know. I need to make sure that something is really problematic. So I need to start digging into that, into that statement of hers. And you know what? It's what they say. If you see it only once, it never happened actually. So in order for me to be able to fix a problem, I need a way to reproduce it. Now, there is the other side of the coin when the boss is coming and say, you know what, I had a problem with the application. You don't even question it. Let me repeat that. You don't even question it. Your boss is always right, so you need to go there and fix it. So again, you would need some tools in order for you at least to pinpoint a problem or to show him some numbers and some nice graphs that he can read. Because if he can read and he can see that, he is happy with your job. Then we will look at some of the options for breakpoints. Many of you might know them already, but for most of the people I've seen that they are just happy with pressing F9 and then pressing a lot of F10s, F11s and F5s, on the same breakpoint until they get to see some good results. And might be time consuming or might be the way we are actually filling our, time sheets. But I will show you some stuff that will improve the way you use breakpoints. I will show you as well then how you can load test your application, because some errors might show up or might surface only when you have heavy load in your application. And of course, you need to be able to reproduce that. I will try to show you how you can profile an ASP.NET application. And because my computer crashed so many times, sometimes it works, sometimes it doesn't. So I can do profilation and it will show me exactly where the error it is. I know already, but I want to put Visual Studio to work, and Visual Studio should show me where the problem lies. And of course, post-mortem debugging. What does it mean? Post-mortem debugging means that you have your application already in production, and you might either get a crash or you might have some problems, and you need to be able to go and take that information about the application and download it on your local machine, and then start to look through it through the dump files and try to understand what exactly the problem is. So I would have a small demo. I just want to show you one application that I will use for today. So let me see where that is. Let's take a Visual Studio. It's already opened. So let's take Internet Explorer. And I have an application. This application, actually, it's a showcase done by Tess Ferrandes. She was one of the girls working actually with debugging for ASP.NET application, and she had a blog about that, and I asked her if I can use her application to show some of the problems you might have with different errors and how you can find them. I won't use, like she does in most of her blogs, WinDBG. I will just try to use Visual Studio 2012 and see if we can get that far, or at least if we can isolate some of the problems in the same way. So it's a site called Buggy Bits. It has two problems that I will concentrate on. The one is called featured products, and of course, any of us had pages on their applications when they need to go and get data from the database, and the server might be loaded, or you might do a lot of calculations behind the curtains. And it might take a while for you to get your application to get a response from the server. So in my case, it takes something like 5.15 seconds. I even put here. Maybe I shouldn't have shown you that, because it's what I do on the server side. So this is actually a direct indication that something is wrong on the server side. But I will show you how you get there and how can I actually prove the same thing using different technologies. And the other problem I have is the reviews here. On the review, if you press refresh a couple of times, sometimes might even crash. The W3WP just disappears as a process, and then I get a new one. And the way to find out is by looking to the event log. How many of you are inspecting the event log regularly? Yeah, okay, that's good. That's encouraging. So very good. So by doing that, you would see what kind of problems you might have in your application. Of course, if you do a rightful instrumentation of your application, you might actually get some very good, very insightful information about what can be wrong on the machine. So this is the application. This is what I want to show you, and the featured product takes 5 minutes, and I want to actually see if that's something that has to do only with the database, or if it's a broader problem that we need to be aware of, and how should we solve that. So, first of all, we need to understand what the problem is. And for that, it's actually the response time equation. The response time equation actually states how should you calculate, or how should you find out how long it takes for you to get a response. And there are different things that you need to be aware of. First of all, it's the payload, meaning how big is the data that you need to get. And this one, you have to divide it by the bandwidth. Of course, now if we want to be really, really, really precise about our calculations, we will have two kinds of payloads. We'll have a payload for uploading when we are sending data to the server, and another one for downloading. And the same with the bandwidth, because most of the connections might be asymmetrical. So depending on the bandwidth, you can get actually a longer time, because a modem, it takes longer to get an answer, and the same for a mobile phone. Then you have the round time trip. How long it takes from your computer to the server and then back, all the communication channel. So if you are flying over Atlantic and you are using Lufthansa's wireless internet, you might have actually a round time trip of about 2-3 seconds. So having someone telling you it takes 5 seconds to load a page, if they are flying Lufthansa and over Atlantic, it doesn't tell you too much. It just, just the way it is. Then you have upturns. Upturns, it means that you might have actually, and you normally have CSS, you have JavaScript, you have other images and stuff like that in your application that you need to bring back. And that's, again, it's something that has to do with the return time, with the return time from the server, and has to do as well with the concurrent requests. Depending on which version of Internet Explorer or web browser you are using, they have support for different number of concurrent requests. Right now, for instance, Internet Explorer, I think from 8 and above, they have support for 6. Other browsers have support for 8. You can actually go into the registry and change that. And Internet Explorer 7 and below, they had only 2 concurrent requests. So, of course, by having a lot of resources that you need to bring from the server, it will take a lot of time to download them if you have only 2 concurrent requests. And then we have 2 more calculation times. One is called CS, the calculation on the server side, how long it takes for the page to be prepared on the server, and then the calculation on the client side, how long it takes for the client to get all the data, or actually to do all the transformations or whatever it needs in order to show it to the user. Here it's actually let's say, a waterfall chart, you can call it, if you want, that shows exactly how long time it takes for me, for instance, to take my review page. It takes roughly 16 milliseconds, and then I have a wait time until it starts actually to parse my DOM and see, oh, you need a picture, you need a style, and then you need something more. So it will just get this information after it has everything that it needs. And based on that, I know exactly how long it will take my application. So let's see which tools we have available actually in order for us to prove that we have a problem. First of all, we have, on the client side, we have a web browser. I wrote browser. So it's a web browser. It's not the Internet Explorer. It could be anything. But you should use that, and you should use common sense in order to see, okay, is the application really slow? Because you might actually get an indication right away that something is not right. But if you know that a specific resource, it takes longer, like going into the database and bringing back the data, and do the calculations there, then it's worth nothing that. Then you have some developer tools. In both Google and Internet Explorer, you have all those developer tools that you might use, and most of them have actually a network analyzer. If you use Firefox, you will use Firebug, for instance. That was the inspiration for all the developer tools out there. So, and that was out for a very long time. Then you have Fiddler. Fiddler, it's a network analyzer application. So you can use Fiddler and look at that, and it will give you statistics, and it will tell you how much different parts of the communication took in order to be able to get the data. You can use something like YSlow. YSlow is an extension that you can add to different browsers like Chrome or Firefox. And YSlow, it gives you indications about stuff that you might change in your web browser or in your web page in order to make it quicker. Why? Because they know exactly how all the protocols work, and you have like 23 different recommendations. And those recommendations, if you use them wisely, you can actually get a very quick response on your page. Of course, if the problem lies on the client side, not on the server side. And there is a new tool out there. I just discovered it actually last week, called Glimpse, which gives you an idea about how long it takes on the server, on the client, and if you have an MVC application, it will show you how long it took every part of the request, for instance, how long time did you spend on authorizing the request, how much you spent on your action, how much you spend on different filters, and so on. So let me show you some of the tools that I was talking about. And by the way, before you go and say, oh, it's the server's problem. Now we know it's actually in my application, it's the server's problem. But before you go and say, yeah, that's a server problem, you need to fix it, I think it's worth investigating that. I have a good friend that works actually in a company that does a lot of hardware acceleration for HTML, for the HTTP protocol and the HTML files. And he told me like 80% of the times it's not the server fault. If you look at this previous equation, and you would realize that actually the server time is 1 second out of 10 that it takes for you to load the page, then you might not actually gain too much by improving the performance there. But you really need to make sure that you understand where the problem is. So let's look at my page, and let's take some of those tools. If I start the application, for instance, if I look with that, I can take and I can do an F12 in the Internet Explorer, and the F12 will show me some of the developer tools. I have a console, for instance. If my JavaScript, if I have JavaScript on the page that sends different messages to the console, I can see them here. I can see the CSS. I can even change the CSS in order for me to see how my page will change. I can do some profiling about how long it will take, and how the memory is used. But what I'm really interested in is actually to say what's the problem. So I would work with the network tab here, and I would say start capturing. When I start capturing data and I do a refresh, it will show me that nice that nice graph that I showed you a little bit earlier. Of course, very skewed. Why? It took 5.03 seconds only to get the first page. So I have actually a pretty good indication right now that something might be wrong on the server side. Of course, for some reason, every single time you restart Internet Explorer, it refuses to have the allow cache. It refuses to have the allow cache flag set up. So I need to do it always to check it. So I want to refresh from server just to see if other stuff have some problem. I might get a very quick response here, for instance, although the page it takes 5 minutes on the server side, just because it is cached. So I can get this kind of functionality. So I can still see that it takes 504 seconds. I can get the same kind of results by using Google Chrome. So let's go there. Actually, yeah. And let's start I don't need Firebug, I actually only need this one. And it will show me how long it takes to run my page. So I'm on the network page. It will go there and it will show me that it took 5.13 seconds. It says I was blocked for 1 second. It took no time actually to send the data. It was under 1 millisecond. I was waiting for 5 seconds, and after 5 seconds, I start to receive data from the server, and it took 3 milliseconds to receive the whole information. And then the next one, how long it took, and what did it do when it was sending, waiting, and receiving. So you can see that actually I get some waiting time as well in there, like 3 milliseconds. I'm waiting for the answer. I can use Y-Slow as well. Y-Slow, when you use it, actually you can analyze a page. You can analyze any page you want. I will just analyze this page, because I want to see if there is something I can do on my client side, on the resulting page here, to improve the performance of my application. So I would say run the test. I can choose what kind of rules do I want. The classical ones were like 15. Now in version 2 there are 23 different rules. I can choose which one I want if I don't want to run all of them. And when it's done, it will show me actually a grading about how long it took to do different things. And I get some recommendations. And based on that recommendation, actually I can improve the response time, or I can improve the response time from the client side perspective. Does it make sense? Okay. So, and I told you that there is another product called Glimpse. Glimpse, you can add it actually to your project as a nugget package. You can just say install package Glimpse dot whatever you are using. If you are using ASP.NET, it will take ASP.NET. If you are using something like MVC, you can install the MVC and the right version of it. And it will add hooks into your application to give you information in real time about what's happening in the application. By default, it's working only when you are on the local host, and if you install Glimpse, you have a what's called a handler called glimpse.axd. If you go there, it will give you the possibility to turn it on or turn it off. I can turn on Glimpse, and by turning it on, it will set up actually a cookie, and it will tell me now I want you to use Glimpse. And if that cookie is set, it will read all this information. So let me go back now to localhost, and let's do an F5. And it will tell me that the request took 891 milliseconds, on the wire 7 milliseconds, on the server 395, on the client 489. So it gives you a pretty good information about how long it takes for your application and where the problem might be located. Let's do it with the featured products to see how it works over there. And you can see that it took 5.144 seconds, where 2 milliseconds were on the wire, 5.029 on the server, and 113 milliseconds on the client. So you get the good feeling about where the problem is. Now I know that the problem is somewhere on the server. So I need to make sure that I can actually locate that. By the way, there is another one here. You can look at Glimpse and you can see some of the configuration, some of the information. You can get actually all the information about IIS settings you have. So it's a pretty good tool for you to get actually a glimpse into what's happening with your application. Trace, it's not working with ASP.NET Web Forms, but on the other hand, it's working with MVC. So if you have an MVC application, it will always show you all the methods that were called and all the trees. So you would get actually a chance to even pinpoint to a specific method that might generate problems for your application. Okay, so let me close that. Let me turn it off because we don't need it anymore. So we do the right functionality here now. And I'm closing this and this. So of course, the next step for me would be to go into my application. And when I do that, I would need actually to set some breakpoints. I want to make sure that, if something happens, I can get a chance to actually get an information about that. There are tools like IntelliTrace, which is part of Visual Studio. I think it's available only on the Ultimate Edition. You can use IntelliTrace in your application if you have it locally, or you can have an agent running on your production server that will collect all kind of events, like if you have an error, if you have an exception, whatever you are reading for the database. But I won't go into details about IntelliTrace. I think there is a whole session about IntelliTrace. I really recommend you to go and watch it. But when you work with breakpoints, beside the F9, you can actually add different things for the breakpoints. First of all, you can specify a location. If you can say by hand exactly where you want to have it, or you can actually, after you add the breakpoint, you would see exactly in which file at what line the breakpoints are set. Next one would be a condition. You don't want to stop every single time. You just want to stop when something happens. You have a hit count. You know that something happens only after you do something like 100 times you did a certain thing. So instead for you to stay there, you can actually only use the hit count, and then you can have it after that amount of time. You can use filtering. You can filter actually if you have several processes that you are debugging at the same time. You can filter by processes. You can filter by the thread names. You can filter by process IDs. So you can do some filtering on the breakpoints just to stop exactly where you need. And when hit, it's actually called a trace point. You can specify what should happen when that particular breakpoint gets hit. You can log some information to the trace file or to the debugger output if you run inside Visual Studio, and it will put that information, and you would know, okay, I can watch here now and see that this was happening. And you can combine that with the hit count and with a condition. The only problem is that when you have this kind of when hit or the tracing functionality, the default behavior, it's not to stop anymore. So it won't stop at the breakpoint. But you can change that and you can say, now I want you to stop there. So let me see. This is Visual Studio. I think you know it. You've seen it before. I assume that at least. And I have an application. And I know, for instance, that my crash, it's happening somewhere in this review. I got somehow the information, but I need to do some testing in my application in order to get there. So let's start it in debug mode. And let's see if we can actually reproduce that error when the application it's crashing. I know that application is crashing because I got that information. So let me, from my event log files, go back here and set that startup project and run it. So, this is the application. I'm running it in IIS in the debug mode. I can do reviews and I can press refresh a couple of times. And when I get the problem or when I get the exception, it will stop in my application. So what I have here, it says to me, oh, this is a null. You have a null reference exception. So luckily, I could catch that kind of problem already in my I could catch it on my development machine. So now I could go and watch and see, okay, what am I trying to do? Oh, you are trying to set code to see if it's empty or not. By calling those to string to a null object, automatically it will throw an exception. And if you don't handle the exception, it will actually kill the process that was having that particular exception. When will that get run? And who will run this method? Do you know? Yeah. The finalizer thread, actually. So there is a finalizer thread that goes and runs all those destructors. So how it works, normally when you get the garbage collection, your object will not be removed if it has a destructor. It will just be moved on a special queue, and from that queue you take object by object and call their destructor method. And then next garbage collection will remove actually the object. So make sure that if you have a destructor, you make the object disposable. Look only, there are a lot of blogs out there. Just look for one of them and see why would you want to use disposable. So normally, if I would have used disposable, I would have take care of the data or this cleaning up already, but somehow I forgot. Or I do have a disposable, but some of my developers forgot the fact that they need to call dispose, or that they can use the using statement, with my particular object because I implement the disposable interface. So, of course, this should happen very rarely. The destructor shouldn't be actually called, but if it happens, then, we now find out that we have a big problem. So we need to fix that. Let me close the IntelliTrace because I don't need it. I did actually here. I'm trying to do, to simulate that one of three of my developers forgot to actually call dispose on my object. So if I do a randomization like that, it won't crash every single time when I press the button. But right now it did crash here, so I have this. I have the problem. So how would I find what the problem is? I can go here, and because I don't know exactly that this is the case, I can actually look and see who set that quote to null. And I can do like this, and I would say insert breakpoint. And now we have a bit of a problem. In Visual Studio, you cannot have something called data breakpoints, meaning I can't put a breakpoint on that quote and say, okay, I want you to stop when this one is null. So how can you solve this kind of situation? Well, the easiest way to do that is to go here and say, convert that quote actually into a property. So let's see, refactor, encapsulate field. So the property name now would be quote with capital letter. The field would be name quote as well. And I would say OK and update everywhere, apply. So now if someone wants to change that, including locally, I can actually do here like this. Oh, no, let me do that instead. I would call this quote would control. Let me do that. I'll call this quote, and this is quote, and this is quote, and Q control dot rename it. Let's see. So I actually created a property that it's called exactly as the field. So even inside my class, it will be called by the application. And then I can put a breakpoint in here. So if I put a breakpoint in here, then I would actually be able to run the application. Of course, because I put that, every single time someone tries to write a value in there, it will my debugger will stop there. So I will do here, I will go to the reviews, and then I will have to do like F5 couple of times just to see what's happening. I can go here and even look at the locals and see what the value I have for this or what. Oh, let's do a refresh first here so we can stop here. I can look at the locals and it will show me, come on, underscore quote. So something is wrong here with the Visual Studio. It doesn't show the line as it should, but it says null here. The value, it's actually, I have never seen such a buggy code, and we look for a couple of times. The value actually has different, it's different every time, meaning that we write the correct value into it. We don't write any null. So we don't hit yet the bug. So let's do some more, and nothing happens. So the application runs correctly. I press refresh. Let's see. Now it stopped here. The randomization actually was 1. So it showed me now someone tries to null that value. And if we look on the call stack, we can find out actually exactly where that happened. Windows, call stack. And I can see that someone here called the finalize method and was trying to write the value here. Oh, so that's correct. That was not a problem here, actually. So we can continue. And again, it should stop to the next one. But now we already hit that problem. So someone actually set that up, and I can see that the value was already null. And although, because it was called from another thread, from another thread. So the way for me to stop only when something like that happened, I can say condition, and I would say value equals null. So when the value becomes null, then I would actually stop. Only then, not always. And then I can go back on the, look on the call stack and see exactly who sets this one to null, and then I can actually solve I would go in and say, this is how you solve the problem. So back here, refresh. So now someone set it to null. It's the finalizer, so it's not a problem. Let's continue. It's the finalizer, not a problem. Then it's okay. And then do it a couple of times. We will see that at one point we will stop actually in this method that's called clear review that will try to set the quote to null. Yeah, so fixing that problem won't be that difficult, or at least I can make sure that the destructor is not called all the time when it shouldn't be called. I can transform that into a trace point by doing the when hit, and I would print a message, and the message would be actually information about that. I could even have some data from whatever I have in my application, so I can take the value here and put it in there, or I can take this dot something. So I can print this information, and it will show up in my output debug window. If I want to stop there as well, not only to write the method, I need to clear that flag to not continue when the execution. So I want it to stop. I don't want it to take the breakpoint and then continue to run the application. Okay, so now we know that this is a problem. We can fix it. But how about us finding out some of the performance issues that we have with our application? So the way to solve that, actually, it's to run something called a web test together with a load test. So let me go here and say add new project. First of all, you would need a test project in your application. If you don't have a test project, you won't be able to add those load tests and web tests for the application. So let's call it load tests. Load test for my application. I would say OK. And yes, use it. And then I can add a new web test. It's already there is already one here. I can go in that. I can change the name. I can give it a name more like something that I know it will do. Okay, let's see. Okay, so load featured products. Yeah, so the way I want to work with it, it's just to, to start record it. And the normal way of running this kind of test would be you go to localhost or to whatever application you have, you get back this answer, and then you go and click on the featured products. And when you do that, you would get actually some recording, you would get some information. When I'm done with it, I can press stop here, and when I press stop, it will start reading the data. The features product from, it was determined that a test with the same ID was loaded, already exists in the catalog. Retry. Okay, so I had a web test previously and I removed it, and that's why it gave me that error. So it will try to find it to see if I have any parameters. Normally, if you have a page that will retrieve data for your application, then you would have different parameters. You might want to send something like a username and password if you want to log in. So there are a lot of things that you can tweak here. But what I'm interested in is just to have a web test here that I can run in my application and see, that something it's going according to my expectations. I can even set up in my solution and say, every single time you do a build, I want you to run all the tests. Of course, you might not want to run load testing and stuff like that for every build, because then you would lose a lot of time. So when I get the web test, it will tell me that, according to the expectations, default page took actually 0.013 milliseconds, and the featured product took 5 seconds. So now we know that we have a problem in there. Next step for me would be to do something like load testing, because I want to make sure that this doesn't have to do with the load. Now, the code is done in such a way that it will show us exactly where the problem is, and the load test, actually, when we do it, it will just give us a lot of errors. So new load test, and now I can specify what kind of load do I want to create. So I would have a scenario, and the scenario would I will call it something when user wants to see the featured products page. Yeah. If I want to have a think time, for instance, when you go to the default ASPX, you don't go and then click directly to the next one. Normally, as the user, you look a little bit around, and then you click the link you want to go to, and then you might click another link and another link and another link. So how exactly do you want that to be done? And I would say, I don't want to use any think times for my application, because I just want you to run it pretty quickly. Next, I can say how many users do I need to run my application. 25 users are not that many, so we can actually live with that. We can see next here, based on the number of tests, how long it will take. How do I want to mix that? If I want to add different tests, so I would have one here that's called actually the load feature products. Why it's twice? Let's see. And OK. I will say next. What kind of network do I have? I can choose everything from a dial-up modem of my that I might find at granny at home, to a 3G, to a cable modem. So it will actually simulate all those the return time, for the server, because a cable DSL is slower than a LAN, and so on and so on. But I'm not interested in that either. I will just use LAN. I can choose different browsers, because different browsers might trigger different kind of work, on my server. I'm okay with that one as well. I can use, if you look at the browsers, actually there are a lot of modern browsers there, including Internet Explorer 5.5 that you might find in various places. But I will leave only Internet Explorer 9. If I want to add some counters in that testing, or if I just want to use the normal ones, I'm not interested in anything special. And how long do I want to run it? I can run it for 1 second, for 1 minute. I can run it for 10 minutes. I can run it for an hour. Normally, when you do it with your own application, you want to let it run a little bit longer. But when you just do it, when I will do it here, I will just ask to do it for 1 minute. Might not be exactly what we need, but it's pretty good. It's good enough. I can as well give it warm-up time. So for instance, if you work with an ASP.NET application, you know that the first time you go and try to hit the page, it will take time for the page to get compiled. And if you want to avoid false positives, and information that is not really what's happening, you would like to give it some think time, and try to actually run it a couple of times and just ignore the values. It will run the test, but it won't read any value. It won't add the value at the end results. You can do as well some test iterations. You can say, I want you to do 100 tests instead of that. But right now, I just want to do, like 1 minute with 25 users in my application. And then finish. When this is done, I can just go here and press run load test, and it will start to run it, and it will show me exactly what is happening. I have different informations here, and again, for some reason, my page response time, it's not there anymore. So usually you can see when you have the page response time, you will see exactly how, it takes longer and longer and longer and longer and longer and longer for a page to be shown. So let me try do that instead. Okay. So I have on this other machine, actually, I have some tests that I was running, and I can show you the graphs. So we don't have to wait for it, and it will just show it takes, some time to load the pages. It's always taking like 4 seconds, which is a lot of time. One problem that is here, and I don't understand why it's happening, it's why does my default page takes as long time as the other page. I do expect, I have no problem with this one, for instance, taking here, this page here, taking the featured product one, it's the red one. I don't have a problem with the red one taking actually 4 seconds or 5 seconds to display. The problem I have is with the other one, which is called default ISPX, because I don't expect that. And this is the first page, this is your landing page, this is where your customer will come. Actually, in this scenario, I'm running 250 users, so that's why you see something like that. But the reason you get these kind of errors here, and you will see this increasingly, especially when you have a page that takes a very long time, is because all my request threads are busy delivering, or doing something for that featured page. So when I get to a certain point that I'm using all the threads from the request pool for that, then I won't be able to serve any other requests. So default ASPX would be queued, and then you would wait for a period of time up to 5,000 requests, and after that you would get the 503 server too busy. You might have seen that before, so you know what's all about. But again, going back to my other computer here, I can see that now this is done, and I have a lot of, I have 25 users. I done like 1.82 tests per second, and average test time was 12 seconds. Pages per second, 392. Actually, those are very, very, very low numbers. And of course, the problem with those numbers is because I have some very bad written code. But how do I find where that code is? Well, one way for doing that would be to go and do some performance testing. Let me see something here on the data layer. I had something, like an error that I want to have here, because that will take even longer, and it will show me actually where the problem lies and how this could be solved. So what I need to do now, let me see, this is a result, and this is the load test. Like this. So what I can do now, I can do some analyze, and I can do some performance analyzing of my application. So it will try to connect to the web server and start it for profilation. I will leave it a little bit to give it some time to do that. And when it's up and running, then I can go in and start my load test again. So when I run my load test, it will actually at the same time do profilation on my application. Wait for it. So now it's going here, and it showed me this page. And what I can do now, I can go into the load test and say, run load test. When I'm running the load test now for 1 minute, it will actually add pressure to my web application, and my profiler would actually take information about what can be wrong in that particular case. So it will take 40 more seconds. And based on that, I can actually start analyzing my application. I can take that information, and I can look exactly. It will show me all the hot path. It will show me which method took how long, and where I can get a good indication where the problem was actually located. I had one project at one time. It was using nhibernate, and I was not exposed to nhibernate, so it was just my first time working with it. But some of my colleagues did. And what they did not understand was how the application was supposed to work. So every single time when they wanted to read something from the database, they were reading all the metadata, they were parsing a lot of XML files, they were parsing a lot of strings, and they didn't understand why it takes so long every single time you want to do, you want to have a request from the database. The database was okay, everything was okay from all other standpoints. By doing this kind of profilation, it showed me that I'm actually calling string.format so many times, and then looking up the stack, I found out that actually the XML parser is actually very hot on that list. And then after that, going on, I saw that it's nhibernate that reads the metadata that has actually a problem. And then reading the documentation, they say you don't have to read the metadata several times. You just read it once when you start your application, and that one you will cache it. And by just doing this small change, all our requests went from, taking a couple of seconds to take no time, actually, because we didn't need to parse a big metadata containing information about the files. And this is something that it's, easily could happen to anyone. So now I'm done with it, and I can go back here and close this. When I close this, it will start now to read the information. So the profiling now it's finished, and let me see. And it will try to show me some of the information. Now what's happening is that it's starting to load symbols about my DLLs, or about the DLLs that I'm dependent on. Why do I need the symbols? Because that would give me a more accurate information, which method was calling what method, and so on and so on. When you do profiling, you have different kind of profiling that you can do. One of them being actually sampling, the one that I just did. What does it mean, sampling? Sampling, it means at a regular period of times, the profiler will stop my application and will look what methods am I in right now. And it will record the methods and their call stack. So I would know exactly from where I got there. And it's pretty accurate. That's what it's actually very, amazing about it, because you don't lose too much time and it doesn't add too much to the performance of your application, or it doesn't increase or it doesn't decrease the performance of your application while you are doing the profiling. So this is a very good way actually of doing it, and they have shown, during the time, that even if you take a sampling at every second, it's still good enough to give you an indication what your application is doing and what can be wrong with the application. After that, you have the instrumentation, and in the instrumentation case, what you are doing there actually, you are let's close that one. I don't need to see it. In the instrumentation, you would add all the information about your application. You would add all the information about, you will instrument all the method call. So you would add a log, a timing when a method is called, a timing when the method is returned. And doing that for all the methods would actually add a lot of overhead to your application. So while it might be very good in your development environment, if you really want to find what's going wrong, this kind of profiler, this kind of instrumentation can actually take a very long time and can give you big performance hits with in your application. So I don't really recommend it always to be used, but it's a very good way for you actually to get to the core of the problem. So let me see. Normally, if this one is okay now, let's see. Call tree, Internet Explorer, and no. Come on. It's the wrong application they took actually. Start, Launch Performance Wizard, CPU sampling, the one recommended. I want to take the application, ASP.NET application, URL, local host. So let's see. Go back to the test. That's the features. That's the load test. Run it. Yes. So that's good. It's running the process ID 538, which is our W3WP. So I can run that. I don't need to run the whole profiling because I know exactly where the problem is. So if I press stop here now, I don't want to do it till the end, and I will close now this Internet Explorer. It will say I got enough data. I will save it there, and now let me do some analysis of it, and let me show you what's wrong. On the output, you could see all the symbols that gets loaded. Again, I cached all those locally, or those that I had access to, I cached them locally on my machine. And the way to do that, you go into the Tools, Options, and you specify where do you want to take the symbols from. There is a symbols tag here. I'll put them on my D drive, and there is a folder called Symbol Cache. So if something is not on the cache, it will try to go on the Microsoft reference server and bring that from there. Then it will go to the Microsoft symbol servers. I can do my own symbol servers as well and put them there. And that's actually something that is recommended, especially when you do a build process on a TFS. You have the possibility to check there and say that you want support for symbols and for sources as well. And if you do that, whenever you do debugging like that, it will take you exactly to the right file. It will take you to the right DLL as well, as long as you have access to that, or you can reach the TFS server. So going back here, let's see. Summary, call tree, no. Where is the W3WP? Okay. Okay, yeah. Let's. Actually, I think I can remove that and I can leave only those. Let's remove that permanently and run it again. Come on. Okay. Detach. No. Actions. Launch. Now, so anyway, the whole idea here is because I have the symbols, it will show me that one method that is actually called most of the time from my DLLs would be a method called here in the domain services. It will go into the data layers and it will show me that in the data layer I called actually the get featured product, and in that particular method everybody is actually calling this log sync object. And because I do that and I want to see only my code, it will actually show me directly there. For some reason doesn't want to help me here. I will leave it like this. I will try to see if I have it on this other machine saved already. If not, I've done it several times and I can find actually the hot path of my application. But now we found the problem, but we still got some reports that our application now crashes in production. So how can you do that? How can you work in production? How can you find if there is a problem with your application or not? So let me close that. And let me show you some of the tools that are actually available for that. One tool is called Debugging. Debugging is actually a tool from Microsoft that will allow you to create debug diagnostics. And you can create different rules, for instance, what should happen and which rule you want to have active and so on. So I know that there is a crash and I can choose the kind of crash, that I can choose this kind of rule for my application. Then I say next, and then it will ask me which one do you want to work with. And it's actually, let me do that. It's either an IIS or COM+ process, or I can say, you know what, I know it's an IIS web application pool, a specific one that I want to choose for my analysis. And I'll take the default application pool because I know that my local host is actually into the default application pool. I would say next. What do I want to do if I wanted to handle some exceptions or only specific exceptions or all of them that might occur? I would say next again, the name of the rule, how it's called, and where do I want the dump files to be added. So I have a folder called dump files where I want to save it, and it's default app pool. I want to put it in there. Next, it will tell me that the folder is not there. Okay. Create it. Of course, I need to learn how to spell. Activate the rule now. By activating the rule, it means that it will start to... okay, it's that one, yeah. So if I want to run that, it will automatically activate the rule. So let's right-click and say activate rule. And when that rule is activated, it will listen to my process, to my specific process, to my default application pool, and as soon as I get a crash there, it will generate a crash dump. So let's close that. Let's go to the reviews, and I will click refresh a couple of times. And as you can see, because I got the crash now, user dump count went up to 2. I can analyze the data already here. There is one problem though, because I don't have any PDB files related to my own application. It cannot actually go and give me the information. If I would have put that into a symbol server, then debug diagnostics tool would have been smart enough to show me that information. Let me do that. But I will show you how a dump file looks like when you load it into Visual Studio, and you have access to the symbols for all the libraries that you are loading, and you have access to the application of to the PDB files of your application. If I would load that in Visual Studio from this machine, it takes around, it takes about 2 to 3 minutes actually to start the debugging. What I can do here is open, I would say open file, and I know that I put the files on the C dump files, and it's called crash rule for iApplication. It's the one at 659, and I would say open. Let me close some of the windows here. Close that, and that, and that. Come on. And it will tell me you can start debugging that, and I can start debugging that with mix mode. Now it will start to load all the DLLs, and it will look for symbols, and it will give me some information for which one it managed to do and which one did not manage to do. Oh, this one actually went pretty fast. And it asks me, do you want to continue debugging? And I will say, yes. Then it will load some more, and then it will tell me, okay, now we found the error. Do you want to break here? And look where it stands. It showed me exactly that. You can do that in production without having anything. You can have that in release mode compiled. So it doesn't have anything to do with the fact that it's compiled in debug mode. If you have it in release mode, the only thing you'd have to do is to set up your build process to include all the information about your about the PDB files. So it should generate the PDB files. Save them, because then you might need them later. Microsoft publishes all the PDB files that they are generating. There is one problem though. On Windows 8, all the native files do not exist on Microsoft servers, because the native files are actually ngenned on your machine. Meaning that Microsoft will run ngn for each of the assemblies you have, and it will create one called the same.ni.dll, which is the native information. But you can create PDB files for those. How? By running ngn manually, and you have a create PDB verb that you can use with ngn. When you do that, it will create actually that PDB file, and you might specify exactly where do you want to have it located. And I put it exactly on my cache folder. Where is it? Let me go here. So in the folder I got the cache for this one, I said it's D, symbol cache, and here are all the files. So as you can see, I have windows.media.ne PDB. So I went through all the DLLs that are in my GAC, and I was generating those PDB files. Having access to them means that it's much easier for me to do that. As you can see, I have two different versions. One is the 64-bit, the other one is the 32-bit version of the DLL. So both of them were actually ngenned, and for both of them I created that PDB file. The biggest advantage is that you get this information, and now you can load that. Of course, if you have some more advanced problems, if you want to look into thread stacks and stuff like that, you might need to use, at the end of the day, WinDBG. But here you can get a lot of information actually about a lot of the things here. Debug. Where is Windows? Windows. And I can take threads, for instance. And I can see all the threads that I have defined that are running at that particular time. Remember what I said, this is a post-mortem, meaning that I can't continue running the application, because what happened, I was just taking a picture of the process memory and put it on disk, and then I took that picture and put it and put it in a file, in a MDMP file, in a mini-dump file. Sometimes you don't have access to the user interface. So what can you do then? Well, you can use different applications. If you have a telnet access, or if you can have a prompt that you can work on the server. You don't have the remote desktop, but you have the possibility to do some remote access into it, and you have a command prompt there. You can actually have different. You can use some other applications. One of them is AD+. AD+. You can use it. Let me do that. CMD, run as administrator. Yes, and let me put it here. Okay, so if I write AD+, I have it in my, it's plus, not pulse. I said that I need to come on, cd dump files first, and then I would have c : / program files / sysinternals. So no, that's actually from the debugging tool for Windows. So I need to, yep, it should be here then. CMD, oh, it takes me always to this one. Then where is the AD plus? I know where it is. It's here. I never add it. Actually, on this computer, I never add it to my search path. It's on the program files, Microsoft debug tools for Windows. No, it's on the. Okay, I will go back to that. But I will show you another tool which is called dump proc. No, C : program files, sysinternals, suite, dump. So cd, like this. It's called proc dump, like this. And proc dump has some nice features. For instance, I know that something is wrong in my application, and I want to find out first what it is. So I can do like dump proc, and I would say, give me all the first chance exceptions. Come on. E1. Okay. -F. Something is very wrong with my computer now. Let me close Visual Studio for a moment, because I think, oh yeah, I have loaded that file, but it stopped, okay? So, yes, save the session. So, I can say, give me all the first chance exceptions, and I don't know the name of it. So, I will do that. And the name of the process, of course, is W3WP. I want to take that. So someone is already in debug mode. I closed that. Oh, yes, this one. Sorry. I need to stop that. Disable the activate rule. So I'm not connected to it anymore. And now I can go back and say, you know what? Take this. W3WP. Take this process. And now it's waiting for me to do something. What exactly? I don't know, to get the problem into the application. So I can go now again here, and I can do the localhost reviews, and I can try to crash it and see what's happening. So when I get the crash here, it says something called system.null reference exception just happened. Then I can use this information, and I would say, mark, I'll take this one from here, and I would put it as a filter. It's a null, space AP, null reference exception. So it will do the same as before. It will wait for the exception to happen. And when it's happening, it will create a dump file, and it will put it on the server. Now I can take that one and put it on my local machine. One thing you need to be aware of is that if your server it's a Windows Server 2012, then you would need to regenerate all those PDB files from the native images, because those are on the server. So it won't take your local ones. It needs to have the one from the server. But you can easily generate them, dump them on a folder, and then copy the folder on the machine that you want to do the debugging. So it's not only the dump file that you would need as well the symbols from the server. Okay? Let me see. Where are we at now? Okay. So slideshow like this. So to conclude that session, we looked at some of the client tools for debugging. We saw how you can use, for instance, how you can use stuff like the network panel from different browsers, how you can use YSlow to get some indications what might be wrong with your HTML page or with the end result of your application. When we found out that it's on the server, then we start looking into those breakpoints, how you can work with breakpoints in your application. Then we start to some load testing in order for us to isolate the problem. And I wanted to do that together with profiling of ASP.NET application in order for me to find the hot path and where exactly the problem, is. Again, by crashing that so many times, I think it's, something went just wrong. It didn't want to do that. It didn't want to profile the W3 WP anymore. But if you do it from your machine, you would actually get the information and you would be able to see exactly what was happening. And we looked into some of the post-mortem debugging, where you can use either debug-diag, you can use the proc dump from sysinternals, or you can use the AD+, that's part of the debugging tools for Windows. So AD+ just takes the name of the process or the process ID, or you can specify -IIS, then it will dump all the IIS process or the W3, WP, and other processes that are loaded by the IIS. And then you get the dump file, which you can take and open on your machine in Visual Studio. And if you have access to all the symbols, it will give you access. It will give you exact information on the source code, what went wrong and what exactly was happening. You can look, if you have a crash, for instance, you can use that. You can even use debug-diag to say, I want you to take a process, I want you to take a dump, a memory dump, even when you have a page that takes longer than a certain amount of seconds. Because then I know something is really wrong there as well, and I want to have this information. And you might find that you have a deadlock, or you might find that, a thread was running for too long, or you were waiting actually on the database. So you can get this kind of information as well from the application. And debug-diag, it's actually a pretty neat tool for that. I want to thank you for today. And there are some drinks on the other side, I think, right now. So we can go there and, conclude that first day of TechEd Europe. Thank you very much. And if you have any questions, we still have another 5-10 minutes to, let me see how.